Hello, everybody. Look at this as a key card. Just imagine this key card. It's an ATM card, but imagine it's a key card anyway. So this is an admin key. Many protocols have something like this. Somebody is in charge who can control maybe like a God mode, turn off the protocol, getting into safety state, whatever. Most protocols have this, and some people think that protocol should not have it. This talk is about things that are already in protocols that we know today. Chain level phrases, protocol pauses, modal parameter changes. And today we are going to discuss that as legitimate overrides. I'm going to keep this here, just in case we come back to it. Oh, how do I go back?
With the green button.
Great. Okay, so in crisis mode, the paradox is that in crisis mode, most protocols or communities actually want the protocol team to intervene. Say there's a hack, for instance. We see the community, trying to get some kind of intervention. Let's stop this from happening. Let's interrupt the hack, let's kind of blacklist this bad actor. But when there is no crisis, that becomes a problem. Why is there a capability to blacklist somebody from using this protocol? Or why is there a capability to your USDC or your USDT to blacklist your wallet from actually transferring tokens that are legitimately your own? So we decided to go back in time and assess over 705 cases of hacks from 2016 to 2026, January. And we assessed them and we found some very interesting results from the data. 1.33 power law exponent. What does that mean? That means that when there's a hack, for instance, on the protocol, only or mostly heavy-tailed events have the capability to completely change whatever security measure any protocol has been able to protect themselves over the years. Everything is heavy-tailed. So I want every one of you here to leave here after this talk with three things. First of all, I want you to be able to leave here with the knowledge that intervention mechanism is a design space. So it is basically an engineering problem you can actually solve for, not just ideology. The second problem is I want you to be able to differentiate between bounded responses and just blunt responses. And then the third thing I want you to leave here with is understanding or being able to define what is the right intervention for a specific kind of crisis. So before we go further, we should try and understand what is the history of intervention, how the space for intervention in blockchain regime evolved. We decided to make this into 4 main eras. The first era is mostly governance. Well, let me just mention that the first intervention was actually on Bitcoin, not on Ethereum. We had Satoshi actually, fix a bug on Bitcoin back in 2010. But we'll not go back there because that was long ago. So we're just going to start from the first hard fork that happened on Ethereum, 2016. Then there was also a case of VeChain, where there was a hack. The community decided to implement some kind of blacklist for the hacker. So that means the first era had early interventions where they were just, ad hoc responses. Slowly, the system, metamorphosed or kind of evolved into more admin keys, just like this guy right here. So every system has some kind of built-in admin key. And then the system decided to evolve further and have more systematic, contagious, or whatever reactive kind of governance. We're talking about the Terra FTX situation. So, Terra blows up, Anchor is already trying to do some kind of governance decision. Let's fix this, let's fix that. That was the first time we had, a major ecosystem-wide level kind of intervention discussion because everybody was affected. But by the time we get to 2014, 2024, 2026, we now have more defined engineering system, institutionalized emergency kind of interventions. So this is just example of hack situations, not just hacks, but every form of intervention between era 1 and 2. You see, there are actually there are quite a few over there. Just a few samples from about 40 cases. So we see era 1, ad hoc forks, starting from Ethereum, then VChain, obviously. But by the time we get to era 2, God mode admin keys. By the time we get to era 3, reactive governance. So we see ad hoc governance decisions all the way to core finance, where they are now sub-DAOs and Security Council, and then DYDX also have their, ops sub-DAO. By the time we get to era 4, things are very much institutionalized, properly defined. And from Radiant's capital exploit, where there was a more defined intervention system, all the way to, more recently, USDT freeze by a team, and the most recent one, which is linear blockchain adopting a credible layer, integrating Filer's credible layer. Now, remember the word credible layer, we'll come back to that. So this is how it looks. The 40 cases that we just sampled from the 705. So between era 1 to era 4, we see that there is a lot of controlled intervention from signer set. Signer set, mostly protocol teams, mostly admin keys. By the time we get to, we look at how much intervention from delegated body, that is security councils, emergency sub-DAOs, and then governance level interventions. We see that over $1 billion, about $2 billion were already being intervened and controlled by, the smaller signer set. And then delegated body about 800 million. And then governance just about 300. So what is the problem? The problem from all of this is that the super hacks can completely destabilize every security measures you've been able to properly implement over years of success. Just one day, all of a sudden, we see that step finance is no longer, no more. They've been around for years. They've been successful for a very long time. Just one day, we see that Resolve lose a lot of money, and all of a sudden, no more trust in the system. Just one day, somebody made a swap of about 50 million and got only about 20K or thereabout on Aave, and the system is already, being questioned, even though who cares about who is to be faulted? We need to solve for this. And how do we solve for it? We ask the question, what is the scope we want to solve for? Who has the power or the authority to be able to intervene? And what are the safeguards to bound that power so that it is not abused? This is the scope we can think about. We can think about it on the network level, on the asset level, on the protocol level, the module level, or the account level scope. If you're talking about network, just an example, we have BNB chain, complete shutdown of the network in 2022 to save 570 million because a hacker was already trying to drain that. We see an asset level, we've seen this a lot of time, USDT, a blacklisted account cannot make transactions, or USDC, or we also see that as well on World Financial. Just his son can actually make transactions anyway. About 7 million was locked off his account. We see that as well with protocol level as well. Balancer, Beanstalk, Liquid Kill Switch. Another example, Compound. and then account level, obviously, running attacker. So this is how it looks when you assess it over our framework. You see that the network level still have the most significant intervention cases, followed by the asset, followed by the protocol, then account, and then model. Model scope interventions are usually protocol leveled because it's just like a model. Maybe let's stop the liquidation system from, making some liquidations and whatnot. But still, we see a lot of intervention from sign asset controlled and more increase in delegated body action, and then less intervention from governance processes. So what are we really solving for? We're solving for containment speed. When there's a hack or there's a failure in the system, how fast are we able to intervene? How fast are we able to stop this thing from destroying the system of trust we've built? What is the blast radius we should accept this intervention system on? Do we want it to be all of this network? Or do we want it to be all of just the protocol? Or just on the account that is, that is the culprit? What is the legitimacy cost? If we do this, how much of the trust do we still retain in the system? And overall, what are we really worrying about? Is it a risk versus safety problem or a risk versus risk problem? We want to always reduce the number of costs. If there's a system like an admin key in the system, if there's an admin key in the system or there's none, we want to be able to go from high expected cost to low expected cost. And we can only do that by actually architecting the right intervention mechanism in the system, defining the right response to the events, and also modeling the trade-off. What did we find? We found that after assessing 705 cases, we found that governance actually excels when it comes to deliberation and network level recoveries. But it is not alone, because governance is also combined with some other system of intervention. It could be negotiation, like the case of EULA Finance. It could also be, it is usually often negotiation because there are often always social recoveries. Delegation is a sweet spot. When there's a delegated body that is a kind of security council, then we know that there's up to success level of about 48% with 60 to 90%, 60 to 90 minutes in speed of containment. Then the signer set have the lowest volume, but highest success. The signer set have the highest volume, but lowest success rate. So, what is the sentiment for all of this? We assess that the sentiment could always be defined as either positive or negative, just depending on the procedure. The same mechanism could be interpreted as positive by the community or interpreted as negative by the community, just depending on how much they are involved in it. So we define the tooling and we define the principles. Make sure that the system is precise and also define the stack: prevention, bounded response, and tooling. So when we have this, we have clarity that there's a prevention inbuilt in the system, there's a bounded response, and there's a right tool to assess for or measuring the system. Then enhancing the credibility with more in-depth defense. So what does this mean? This means that we have to define the defense system at every level so that the responses are not discretionary. Instead, we are defining them even beforehand. It could be some pre-execution assertions or defense in depth in order to make sure that when there's an incident, the decisions that are being carried out are already predefined. There are actually three main schools of this in the market right now. We see some of the intervention system on the API level, RPC. They are very easy to integrate. An example is Hypernative. Everybody know them. In block level enforcement, an example is back to the credible layer, just like the Phylax system. What they do is they integrate their own system by defining invariants in the protocol at the network level. So basically, the protocol cannot do X, or if X is being executed in the protocol, sequencers stop it. Now, the more in-depth this integration requires, the more difficult it is to integrate. So, why should anybody even do this? Why should anybody even define this system in their stack? It's actually safer to do nothing. Why? Because when you do nothing, you don't leave any signature. You don't have any risks that your career will be in jeopardy. You don't have any worry that you could get sued by anybody. But on the other hand, doing nothing actually destroys the system, because when something happens, you still lose, or the system loses trust. Yes, you protect yourself, but your protocol or your network loses credibility. This is what the scope and authority of the framework looks like. Is there anybody here who can just mention one memorable hack? Just one hack, or anything at all that you remember? Balancer hack, perfect. Thank you very much. Where do you think balancer hack falls in here? Okay, yeah, but we do know that balancer is a protocol, so it's here, right? So it's somewhere around here. So we also know that when balancer was happening, we also know that Hypernative actually helped them save one of their pools. So we can call it a delegated body, because Hypernative is not, was delegated to do that. So that means this is where we put Hypernative action. So when you have a protocol or you have a network, whatever, this is just a simple way to think about what happens should something go wrong. Do we want to intervene on the network level and give it to an admin key? Then let's think about things here. Let's think about the cell. Do we want to intervene on the account level, say a hacker's account, and we want to use a governance process? Then let's think about things happening here. Well, so how do we make that action we take legitimate? The only way for us to do that is, first, we predefine the actions we will take when it happens, or if it happens. We don't wait for it to happen before we begin to deliberate on what to do. So we can choose optimistic phrase. Something is going wrong. We know that this is dissuading from the business logic of our protocol. We are going to freeze that and figure out what it is quickly. And in order for us to do that, we are going to also make sure that the actions we can take are predefined. There's a registry. And also, we are going to make sure that it is not retroactive. Gnosis is already doing that. Just after the balancer incident, like you mentioned, Gnosis is already discussing a framework right now where they're trying to move from an ad hoc response to a more clear emergency framework. It's going to create a system of record, discuss all of the trade-off, and also have clarity on what to do, or what the Gnosis DAO could do when there's a kind of hack that impacts Gnosis. This is very good because it sets the path or an example for DAO. networks to, consider. So, what is the next step you are going to take from all of this? We have been able to do this research, and we have also make all of this data open source so that you could, go check it out, read the paper. But you should value the contribution from all of this, because now you have a framework to think about incidents before they happen. You have a way to plan for them because we've provided a taxonomy for it. We have a clear framework for you to actually plan, prepare, and execute, and respond non-retroactively. Choose the right choice. Make a choice for the right cell that works for you. Publish your constraints so the community knows and see everything that's going on. Build credibility and legitimacy. Measure the sentiment. Decide prevention versus intervention. If there's going to be intervention, what is the things you have to do? Define the instrument and the audit of all of those actions, should you take any of them. And very welcome to explore the framework at liveresearch.org. Any questions?
Hello, thanks for the presentation, it's very lovely. And thanks for sharing the data. You mentioned Gnosis. I'm still waiting for my money back after they forked. They still have it on Genesis contract, and they still haven't given me my money back. So they are the guys that owe me money now, right? They forked, so I can go to Gnosis company and tell them, hey guys, you have my money, I want it back. That's the issue if you fork, right? You are now responsible for handling the money, and why didn't you do it earlier, right? So philosophically speaking, if I never add a pause, I cannot do anything wrong. If I add a pause, suddenly I'm responsible for any hack, right? So you can never be, the best way for me game theory-wise is not to do anything, right? Maybe that's more of a philosophical question.
Yes, that's very good. I think that will take us back to this. When you do nothing, obviously it's safer, right? You can't blame anybody, and nobody's getting sued. But the system is not safe. My reputation is safe as a career, just an individual in the system. I don't get to lose anything. I don't get into trouble. But the system itself, you're asking other people to put their money in this system. Is it safe? Is it trust? That is the problem. So we are trying to do this, or we've built this framework in order for every decision before it happens to be properly defined and have the community impute into it and build that legitimacy that is needed. So even if there's going to be a fork, like you said, then the community knows the system or the process is involved after the fork happens, should that even be a consideration. Now, the entire plan for all of this intervention system is to make sure that we are as precise as possible. And when I mean precise, prevention is the first is the first step of that precision. Then a bounded response means that it is not just blunt fork, right? It's actually bounded in the sense that it is clear what level of response it can be. And then tooling is part of the stack as well.
Hi, yeah, thanks as well. I have a question to the slide previously where you said, okay, there's the multi-sig signers, they have the highest volume but lowest success rate.
Oh, okay.
And the governance actually the highest success rate. From the data that you saw, I would immediately guess, could it be related that governance decisions are typically, we halt the network, we throw the bomb, right? We roll back. Versus multi-sig signers, I mean, they can only do so much. Is there something to that in the data, or is that really independent?
Yeah, that's a very good observation. So the initial paper, we had a very incredible reviewer who gave very valuable feedback on that aspect of things. So yes, one of the reasons why governance have the lowest volume, as you can see there, just 11%, is because it's usually like the last recourse, right? It's a nuclear option, like you said. Like just like a fork situation, rolls back, whatever it is that has happened. But we also found that it doesn't just work on its own, basically, and it's not really ideal. Because for every time you have to make that kind of decision, it is like throwing a nuclear bomb into a problem that you could probably solve with a machine gun. So you want to define, you want to make it as precise as possible. So if it is an account that you can actually pause or whatever, you intervene in a more precise way. And also just like you mentioned, one of the reasons for the success rate as well for sign asset is because that's where everybody starts out. Every team actually starts there. And then as it matures, just like the system or the ecosystem itself, it moves to delegation. So delegation is a sweet spot.
Any other questions? Okay, then, thank you so much, Caro. Thanks for your talk. And we have the last talk for today from Mark Balandis, To Incentivize or Not, where we'd like to just share our observation on this day and the collaboration between practitioners and research.